Hello everyone, what's going on? Welcome to video tutorial on recursion in C programming language. In this tutorial, I'll be talking about the concept of recursion, its implementation, and some C programs using recursive technique. In general, something expressed or defined in terms of itself is called recursion. In programming terms, a function calls itself is called recursive function, and the procedure of a function calling itself is called recursion. A function is said to be a recursive function if one of its statements in the function is the function itself. Let's see an example here. You recurse is a recursive function as inside the function recurse there is a statement recurse itself which keeps on calling itself. Okay, here is a recursive program to find factorial of any given number. Observe the program carefully. Fact is our recursive function, and under this fact, if n equals 0, return 1, else return n into fact n minus 1. Here's the explanation of the program. As we all know that factorial of any number is always the product of that number and the number minus 1. That is, n factorial equals n into n minus 1 factorial. For example, 5 factorial equals 5 into 4 factorial equals 5 into 4 into 3 factorial, and so on. In the above program, 0 factorial equals 1 is the base case, and n factorial equals n into n minus 1 factorial is the recursive case. Since the factorial can be defined in terms of factorial again, it is possible to compute the recursive formula to find the factorial of any given number. Here is a diagram showing how the recursive function is called and value is returned in backward direction. To calculate the factorial of 5, fact 5 equals fact 4, that equals fact 3, and at last our base case is fact 0 equals 1, and from there it starts returning the value, and we are able to find the fact 5. All the recursive operations are carried out in this stack. Stack is such data structure which follows last in, first out LIFO principle. That is, the last element to get inserted or pushed is the first one to get deleted or pop out. Common real-life example of stack can be seen in cafeteria as the plates are kept in stack. The last plates that got washed is the first one that will come out. Here's another recursive program to generate Fibonacci series. Fibo is our recursive function and n is the nth term, and we know that nth term is always the sum of its previous two terms. Observe the program carefully. If n is small or equals 2, return 1, else return Fibo n minus 1 plus Fibo n minus 2. The program can be understood by looking at this tree diagram to generate the series. Here is an example to generate sixth term, that is F6, which calls F5 and F4, and then F5 and F4 call previous two terms. And our base case is if n equals or less than 2, return 1, and value is returned backwards. Here's the next program to multiply two numbers using recursive technique. As we have already got familiar with some of the recursive techniques, let's first try and generate recursive formula for the product of any two numbers. Let's take an example. 2 multiplied by 6, or 2 times 6, means that adding 2 6 times. That implies 2 into 6 equals 2 plus 2 into 5 equals 2 plus 2 plus 2 into 4, and so on. And our base case will be if b equals 0, return 0. And our recursive case will be return a plus product a comma b minus 1. Now we're up to the last program of this tutorial, and that's finding nth power of any given number. Let's take an example. If you want to find third power of base 2, that is 2 to the power 3, it is known to all that 2 to the power 3 equals 2 into 2 into 2. And we can define power in terms of power itself as 2 to the power 3 equals 2 into 2 square equals 2 into 2 into 2 to the power 1, and so on. Our base case is n equals 0 due to the fact that the 0th power of any number is always 1. And our recursive case is written a into power a n minus 1.
Thanks for watching.